So in this video we'll be seeing about the optional header. The name says optional, but it's mandatory for executables and errors. So let's see the optional header. Before we have seen this DOS header and the DOS stub, and here you can see the 5045 represents the signature. So here these 4 bytes are signature, and the next 20 bytes specifies the file header. So here in the PE bear I have opened this another calc2.exe because it's generated by Metasploit. So this file header also gives the same information, but in a meaningful format, because it's gonna parse the values and gives you some meaning. And the next 20 bytes, so 16 4, so next 20 bytes are the file header, and the next 224 bytes, so here you will have the file header size of optional header. So this optional header is the size changes. So the size of this optional header is specified in this file header. So that is 240. So F0 240. So the size of the optional header is 240 bytes, and starting from this point. And here we have the first member. So I am at the P invoke, and here you can see if you search for optional header, we will have two structures, image optional header 32 and image optional header 64. So for now we will be dealing with the 64 bits. It's almost similar structure. The only difference you get is the base of data. So here you can see the base of code, base of data, and image base. So these are the members, and this image base is the base address, preferred or assumed base address of this executable. So that means this image base value in the optional header, let's say where is this one, so this 14 zeros, so this address is assumed as the base address, and compiler will gives you the addresses for the hard coded values. Suppose there are some like pointers to some integers, so let's say those pointers will get the value from this image base, and if this executable is loaded at another image base, then you need to fix those addresses. So that will be using we'll be fixing in the base relocations. So we'll be talking about that in the upcoming videos. So for now let's just follow through these members. So you will get only the difference at this image base. So here it is 4 bytes, you can see field offset 28 and 32, the next member starts. So the 4 bytes, and here you don't have size of base of data, you will directly have this image base, that is 8 bytes because it's a 64 bit. So the first one is 0 bit 02, and if you go to P file format, and you will have this Microsoft website, and here you can see the magic number. So this is also magic number that defines whether the executable is 32 bit or 64 bit, and here you can see the value is 20B and it has been parsed as NT64. So this we will be using this number to identify whether it's 32 bit or 64 bit executable. And the next one is linker versions, and the size of all code sections. So generally there will be all the code will be merged into the one section, .text section. If you have multiple sections, then all of those sizes combined will be told here. And size of initialized data, if there are any initialized data and uninitialized data, and entry point. So this one is also important. This is the offset to this base address. Where is this one? So if I go and click here, this will point directly to this one, and this is the uh, entry point, execution of the first instruction. Okay, and the base of code and image base. So this is the preferred image base. We'll be loading our executable in the some random image base, and we will also fix imports and base relocations. And this is the section element, so this is also important. So what this section element mean is, section element value is 1000, so that means each section should start at multiples of this 1000 hexadecimal only. Suppose if there is a section dot test1 and it starts at 2000 h. Okay, so and the size of test1 section is only let's say 500 hexadecimal bytes. So then if there is another test2 section, and this section should not start at 2501 h, it should start at 3000 h, because the multiples of this 1000 h, that is the rule for the section alignment. So this is called section alignment. The sections should start at the multiples of this value only. In the same way, file alignment. So the section alignment is in the memory, and this file element is when the file is on the raw disk. If you go to sections, and here you can see here raw addresses. So raw addresses follows these file alignment. You can see 400, 1600, 1800. These are all multiples of 200. So OS major version, minor version, and subsystem. And subsystem also tells us whether it's a GUI or a console application. And size of image. So size of image is total size of the image in memory, not on disk, but in memory. And size of headers. So size of headers is total size of all headers combined except the actual data. So we have seen DOS header, this DOS stub, and the file header, optional header, section headers. So if you combine all of these sizes, that is the size of all headers, 248 hexadecimal. And derived characteristics, and size of stack, reserve, and commit. And one another important thing is loader flags. So these values can be given when we are creating the thread. We will see there. And loader flags should be 0. You can see if some malware can have this loader flags set to some random value. When this loader flags is set to some random value, some debuggers just run this binary. So there is a old version of RDDBG. It's whenever this loader flags is set to some random value, it just runs the executable and you gets infected. And number of RVA and sizes. So up to here we have normal members, and from here onwards these occupy 128 bytes, I think 124 bytes. So you can subtract this 14C minus E0. (14C minus E0), I think 148. So the next are the image data directories. So here you can see the values, but it's very impossible to tell everything, because that's why I'm using this PE parser. So these are the image data directories, and these are the pairs. Sorry, we have the virtual address and the size of this data directory. So we can search for this image data directory. So image data directory structure contains two members, virtual address and the size. So there is an export directory and the virtual address 0. So this is the exe, and exe does not do any exports. That's why we don't have any exports. And the import directory, so the executable imports something, imports some functions from the DLLs, and the starting import will be pointed to this one. So that import is import descriptor, and the first import DLL descriptor will be pointed by this address. And if you go to this one and you go to this exact structure, so we will be parsing this later. Just for now, understand that this points to the first image import descriptor, and the size of this data directory, this is 6C, and we have 0, so that is we don't, that is there are no those directories. And we have base relocation table. We'll be also parsing and updating the base addresses, and we have image address table, so we'll be also fixing this one. So that's all about this optional header. This is like a very important header for the PE file.